Hi, welcome to week 12. We're going to start with chapter 9 for comparative effectiveness research and do a case study of hospital readmissions. This presentation will also be available without the audio so that you can come in and take a look at the SQL code as well as the R code if you want to copy and paste it into your tools. So the case study is going to be about the cost of heart failure care in the United States in 2009, which was reported by the AHA to be estimated at $37.2 billion, a major contributor being high rates of hospitalization. So in this case, a hospital seeks to identify improvement methods for heart failure outcomes. The rate of readmission is utilized as a valuable measure of performance. The AHA in-hospital program Get With the Guidelines Heart Failure promotes stable adherence to the latest scientific treatment guidelines and uses the rate of 30-day readmission as a measure of quality. Improved adherence to heart failure guidelines translates to improved clinical outcomes in patients. Rate of readmission can influence the number of beds available, the distance of referring hospitals, education level, socioeconomic status, type and severity of comorbidities, and age. So our research question is there a relationship between accessibility to emergency services and heart failure 30-day readmission rate? So does heart failure 30-day readmission rate depend on presence of emergency services? A simple logistic regression analysis can be used to determine whether and to what degree do emergency services affect a hospital's rate of readmission. So here's our hypotheses, our null hypothesis, and our alternate hypothesis. Here's our analytics checklist. We're going to do a simple logistic regression. We are going to get data from the textbook SQL database, MySQL database. The files for the SQL commands are loaded in Canvas, and they are also presented here in this presentation. You're going to go into SQL Workbench and extract that data and export that data out to Excel as a CSV file. Then you will import that file into RStudio and you will perform some descriptive statistics. So step 1 is to do the data extraction. Here's the SQL code. You're going to select data from the hospital general information table. There's a join statement in there, and you're going to look for the measure ID of readmission 30. This is what some of the columns look like. You can perform descriptive statistics many ways. In this case, you can get some experience using Excel and the pivot table function for your descriptive statistics. You can also do descriptive statistics in a tool such as R or RStudio. And this is an example of using an Excel pivot table. And there are the results in a pivot table. So logistic regression is considered statistical analyses, and it can be used when the outcome variable of interest is categorical. Just like with linear regression, logistic regression allows for the evaluation of multiple predictors on a given outcome. So if we took a look at table 9.1, we can see in the leftmost column we have emergency services, yes, it was available, or no, it was not available. And then some benchmarking data, better than the U.S. national rate or worse than the U.S. national rate. An odds ratio is a descriptive statistic that measures effect size and provides an index for the strength of an association. The formula is the odds of group 1 divided by the odds of group 2. And here you have an example with the actual values put into that formula. So in this case, we see that hospitals with emergency services have a 7.22 times greater odds of performing better than the national rate. And here we see that hospitals with emergency services have an 86% lower odds of being worse than the national rate. This is just a reminder of what our less than and greater than symbols mean. We can then analyze the data in RStudio. So if we come over to RStudio, we want to first make sure that we import our file from the MySQL database. Here I had named my file Chapter 9 Export. I imported it. There were 276 observations or rows with 4 variables. And as you go through the PowerPoint presentation, you can retype or copy and paste the command line coding here to create a data frame and a summary, and take a look at the results. So this is a lot of statistical data, and what does it all mean? Well, let's start with defining what GLM is. GLM stands for the Generalized Linear Model. We're using RStudio to do this statistical analysis. This can also be done in other tools such as IBM SPSS or SAS. And a generalized linear model can accommodate a dependent variable that is binary or count and does not depend on calculating a mean or an average. Here's more code to put into RStudio. The log odds is the logarithm of the odds, and the formula is here, and P is the probability of success. When the slope is exponentiated, this describes the proportionate rate at which the predicted odds changes with each successive unit of x. The confidence intervals can be derived using the following function. The Wald Z statistic and the p-value from the coefficient section in the coefficients are shown in the output after executing the summary command. Given these results, the conclusion is that it appears that hospitals with emergency services are more likely to perform above the national average on the rate of heart failure 30-day readmission. The presence of emergency services in a hospital is significantly related to heart failure 30-day readmission rate. Hospitals with emergency services have a 7.22 times greater odds of performing better than the national benchmark, and hospitals with emergency services have an 86% lower odds of being worse than the U.S. national benchmark.